In this video, consider the polynomial function f of x equals x to the fourth power minus 6x cubed plus 9x squared minus 6x plus 8. Given that I is one of the zeros, find the other zeros. So we want to find the other zeros of this polynomial function given that I is one of the zeros. Now first, notice that this is a degree 4 polynomial function. So it's fourth degree, which means that there should be 4 zeros. Now it's possible that some of those zeros could be duplicates. So it's possible, for example, to get the same zero twice or 3 times or even 4 times. Okay? But if we count those separately, there should be 4 zeros. We're also given that I is one of the zeros. Now, if I is one of the zeros, that's imaginary. And we know that imaginary zeros come in pairs. So if I is a zero, its conjugate must also be a zero. So I is a zero, its conjugate, negative I, has to also be a zero. Okay? Now just to make sure you understand why negative I is the conjugate of I, think of I as 0 plus I, then 0 minus I is the conjugate, which is the same as just negative I. Okay? So if I and negative I are both zeros of this polynomial function, then that means that x minus I and x plus I have to be factors of this function. So again, if I is a zero, then x minus I is a factor. If negative I is a zero, then x plus I is a factor of this polynomial function. So this is going to equal x minus I times x plus I times something. And we want to figure out what that something would have to be. And incidentally, what would go inside the parentheses here would be a quadratic polynomial. Okay? And we'll see that in just a minute. So I want to figure out what this is. And so to do that, I'm going to divide the polynomial by the factor x minus I. So again, if x minus I is a factor, then that means it should divide into this polynomial evenly. If x plus I is a factor, then it should also divide into this polynomial evenly. And so I'm going to use synthetic division to do that division. So I'm going to write down the coefficients 1, negative 6, 9, negative 6, and 8, the coefficients of our polynomial function. And again, I'm going to divide by x minus I, which means I goes out here. I'm going to go through the synthetic division process. So I'm going to drop down my 1 and multiply. I times 1 is I. Add negative 6 plus I is just that, negative 6 plus I. So now I need to multiply I times negative 6 plus I. And I'm going to do that over here on the side. So I times negative 6 is negative 6I. I times I is I squared. Now remember, I squared is really negative 1. So what I really have here is negative 1 minus 6I if I write that as an imaginary number. So multiplying I times negative 6 plus I get negative 1 minus 6I, which goes here. Now add 9 plus negative 1 minus 6I. Well, 9 plus negative 1 is 8, and we're going to still have the minus 6I. Multiply back. I times 8 minus 6I. So I'm going to do that on the side here again. So I times 8 is 8I. I times negative 6I is negative 6I squared. But again, I squared is really negative 1, which means minus 6I squared is really going to be plus 6. So writing that as an imaginary number, that's going to be 6 plus 8I. So I times 8 minus 6I is going to be 6 plus 8I. Add negative 6 plus 6 plus 8I. Well, the negative 6 plus 6 goes away, and we're left with just 8I. I times 8I is going to be 8I squared, but I squared is really negative 1, so that's going to be negative 8, which goes here. Add 8 plus negative 8 is 0. That's my remainder, which should be 0 because we know x minus I is a factor of the polynomial function. Okay? So what I know right now is that our original polynomial function factors into f of x equals x minus I times. Now if I factor out x minus I, this 1 is the coefficient of the polynomial factor that remains, and since I'm factoring out x minus I, that's going to be an x cubed term. So that's going to be x cubed plus, I'm going to have negative 6 plus I times x squared, plus I'm going to have 8 minus 6I times x plus 8I. So our polynomial function factors into x minus I times this. Now this, since x plus I is also a factor of our polynomial, x plus I should be a factor of this as well. Okay? So I'm going to next factor out the x plus I from this polynomial. And I can do that by using synthetic division on this. Okay? So again, if x plus I is the factor, then negative I is what's going to go out here, and I'm going to run through the synthetic division process again. So I'm going to drop down my 1. Negative I times 1 is negative I. Negative 6 plus I plus negative I will just be negative 6. Negative I times negative 6 is going to be positive 6I. 8 minus 6I plus 6I will just be 8. Negative I times 8 is going to be negative 8I. And 8I plus negative 8I is 0, and that's the remainder, as it should be. It should be 0 because we knew x plus I should be a factor of this. So what remains? Well, we were factoring x plus I out of an x cubed polynomial, so that means this 1 is going to be 1x squared minus 6x plus 8. Okay? So, I know, as we said here to begin with, that this function has factored into x minus I times x plus I times something, and this something is x squared minus 6x plus 8, and we can factor that. So looking at this, we need to find two numbers that multiply together to be 8, that add together to be negative 6. And so that will be negative 2 and negative 4. So rewriting my first two factors, again, this is going to factor into x minus 2 times x minus 4. So I have factored our polynomial function into x minus I, x plus I, x minus 2, x minus 4. Now if x minus 2 is a factor, then that means 2 is a 0. And if x minus 4 is a factor, then that means 4 is a 0. So over here to the side, we already knew that I was a 0. That was given. We used that to figure out that negative I had to also be a 0. And then we've used that to factor, and so we found that 2 has to also be a 0, and 4 has to also be a 0. So here are our 4 zeros of our polynomial function.